So look at the second page of your worksheet. At the top, it says find the inverse. So function inverse just means if I had, for instance, x matched with 2 and y matched with 3 and z matched with 4, that's a function. My function has a domain, it has a range, it has a rule, and it doesn't break the one rule that says no domain goes to 2 ranges. The inverse of that is just flipping the bubbles around. So it'd be 2, 3, 4, x, y, z, and now it travels in this direction. So we can find the inverse of a function really easily. We make a table of all of the x's and all of the y's, and then we switch places. But I think that would take quite a bit of time. So instead what we do is we just write the equation and we switch the x values with the y values. Well, these are written in function form and there are no y values. So where are the y values? The f of x is y. So this is y equals log base 10 of x plus 7 minus 2. So to perform the inverse, everywhere I see an x, I write y, and everywhere I see a y, I write x. So x equals log of y plus 7 minus 2. Now, what that has done is taken my logarithmic graph and reflected it across that 45-degree line and created an exponential graph. The only trouble is we want it in y equals form. So we need to solve for y. And it looks tough, but it's really easy. We want to get the logarithm by itself, and then we convert to exponent. So I'm going to add 2. So x plus 2 equals log, and I'm going to write base 10 of y plus 7. How do you convert this to exponential form? No, we want to get rid of the log. That's the point. 10 to the x plus 2 equals y plus 7. Now I'm almost there. No, I want the y by itself. So y equals 10 to the x plus 2 minus 7. Yeah, it's not bad. So let's do number 2. So x equals log base 6 of y minus 10 minus 3. So I have already performed the inverse. Now I need to solve for y. Before I can convert to exponent, what do I need to do? Add the 3. So x plus 3 equals log base 6 of y minus 10. Now convert to exponent. 6 to the x plus 3 equals y minus 10. So I'm going to add that 10. So y is 6 to the x plus 3 plus 10. So that's not bad. Look down at number 7. This is the opposite. This is already in exponential form. I need to convert it into logarithmic form. So x equals 5 raised to the y minus 3 plus 2. Yes, so I inverted it. Now, in order to convert to logarithms, the exponent term has to be by itself. So it would be x minus 2 equals 5 to the y minus 3. What is that in logarithm form? Log base 5 of x minus 2 equals y plus 3, or minus 3. And then I would just add that 3 over here. And that's the logarithmic equation, equals y. Yeah, that's the answer to 7. So they're all kind of similar. We're going to spend more time in a day or two working with logarithm inverses and such. But that's just practice It's just more practice converting back and forth between exponents and logarithms. Which one? So 3, what is the base for 3? E. So it would be x equals 2 log base e of x minus 8 minus x plus 5. So you're going to subtract 5 and then divide 2 and convert it to an e to the x problem. And then you're going to add or subtract 8 and change both signs, the signs on either side. Does that make sense? Okay. Good luck.